In this video, we are going to do questions of exercise 10.1, chapter circle. The first question here is how many tangents can a circle have? So let's say if I draw a circle, I've drawn a circle. Now I'll draw a tangent. But before you understand what is a tangent, and before we answer this question, let's understand what is a tangent. What you can observe that here the circle and the line has no point of intersection, no common point. Now you can see it has one common point over here. And now this is common point. I mean, 2 point of intersection. So this is the case. In this case, we are saying this is a secant. And when circle touches the line at one point or line touches the circle at one point, then we say it's a tangent. So what you can observe that we can, since there are infinite number of points on a circle, let's say there are infinite number of points on a circle, so there can be infinite number of tangent. Let's say this is another tangent. Say this could be a tangent. So we'll say that there are infinite number of tangents that can be a circle can have. Now coming to the next question, it says a tangent to a circle intersect at dash points. So what you can observe here that over here, this is 1 point. So a circle and a tangent has only 1 point of common. So the correct answer for the second part should be, I mean, the first part of the second question is 1. Now moving to the next question, we got the answer for this. The third one, it says a line intersecting a circle at 2 point is called what? That's called secant. So for example, if I draw a line, let's see, as of now, it has no point. Now it's a tangent. Now it's a secant, right? Because now you can see it has 2 point. 1 point over here, say M, and this is N. So we'll say the answer for this part is 2. Right, and it's called secant. Now the answer is they're talking about 2 points, so the answer should be secant. It is secant. That's called secant. This is the answer for the second part. Now the next question, it says a circle can have dash parallel tangent. So let's say if I see that this is a tangent over here, and if I want to draw another tangent so that it is parallel to the given tangent, then I can say something like this, right? These two tangents are parallel. And now if I try making another tangent so that it is parallel to the given tangent, it is not possible, you see, if I try to make it another tangent. So correct answer will be 2, as you can see here. There are 2. So circle can have at the most 2 parallel tangent. As for the next part, the third part, it says the common point of a tangent to a circle. Yeah, that's called point of contact. Like this is a point of contact. This point, this is called point of contact. So we say it's a point of contact. Now coming to the next question, this is third question number 3, right? This is a circle PQ, a tangent PQ at point P. So let's say I will use the same figure, but I have to make, let's say I draw a new circle. I've drawn a new circle and I'll take a point P on the exterior, right? I took this point P. Now I'm going to draw a tangent from here. Let's say I draw a tangent from here, a circle, a tangent PQ at point P of a circle. Okay, fine. So this point is P, right? So I'll have to rename this. This point is P, right? So a tangent PQ of a circle, P of a circle of radius 5 centimeters. So this being the center, and if I draw its radius, I'll be joining this. And I name this as O as per the question. Okay, and this must be Q here. As you can see that the tangent PQ is there at a point P on the circle. That means P is point on the circle and Q has to be the exterior point. Now further, as I read the question, it says that what we have to find out, other thing is given. The length of OQ is also given. So let me join OQ. So if I join OQ here, O with Q, I've joined it. And the length of this OQ is given how much? This is 12. This length is given 12. And the radius was given 5. Now, what do we have to determine is the length of PQ. All right. So to get the length of PQ, what you need to remember that radius is perpendicular to the tangent at the point of contact. Radius is perpendicular to the tangent at the point of contact. So we can say that this side, the side opposite to right angle is called hypotenuse. So we can apply Pythagoras theorem over here, or OQ square is equal to PQ square plus OP square. Now let's plug in the value. OQ is 12, so it's 12 square. PQ is how much? Is what we have to determine. And the length of OP, which is the radius, given as 5. So this is what? 144, and this is 25. So if I bring 25 on this side, it will be subtracted. That will be equal to PQ square. So their difference comes out to be 119 is what? PQ square, right? So if I transpose this, if I have to find out PQ, the square will become under root on this side. So the length of PQ comes out to be 100, under root 119, right? So here there's a printing error. It should be under root 119. Now we have one more question left. And let's erase this first. Right. The question here is to draw draw a circle and two lines which are parallel to the given line such that one is tangent and other is secant. So what we will do here, first we will draw a circle here. Then taking any point on the circle, let's say I choose this point P, we will join with the radius here. Say this is the radius. This is the center of the circle. And now using compass, you can draw a perpendicular, right? At this point, taking OP as the base, we will be drawing a perpendicular. So if I draw a perpendicular, it should be like this. And you may produce this on the other side as well. Okay, produce this on the other side. So this is what? This is what we got a tangent. Now take any point somewhere on PQ or on the extended part of PQ. Let's say I took this point as R. I took this point as R. And now again, we will draw a perpendicular over here, right? A perpendicular that is 90 degree. So what you can observe here that the yellow one, this is a tangent and this is a secant. As you can see here that this green line is intersecting the circle at 2 points. So this is a tangent. Sorry, this is a secant, the green one, and this is a tangent.